Hi everyone, welcome back. This video we're going to be looking at just basic queries one more time using select from and where. Typically in the database manipulation languages, these are similar to relational algebra. A is going to be our attribute or the column that we're looking at. R is going to be the table that we created. And then the where is where we have our predicate as well. So again, this goes back into conditional logic that you learned in previous coding courses too. Excuse me. I wanted to show you a bit about why, I want to show you a little bit of the background of these two, but I think some of the coding will be helpful as well, as the slides are up there too. One more thing that we saw in the videos, these all the code that we're using is case insensitive, which is a bit of a difference from what we're used to. The only thing that I'd remind you of is that we usually use a semicolon to go ahead and select everything from there too. Okay, so the select clause is something that's pretty unique where we can also create variables and relations in real time with our code. And one more thing that is interesting here is that we can also do arithmetic expressions with our select clauses in real time and output them as their own kind of attribute as well. So we can rename this type of output here using an as clause too. And we'll go ahead and look at some examples of this before we delve into our actual, code here. So I'll upload, this is from the previous video of lecture tree here. So you can go ahead and use it, or if you want to create your own version of this stuff too, that's fine by me. So let me run these two. Oops, drop both these tables. So we're going to create our tables again with our foreign key constraints, and we're going to go ahead, try to run all of our data. Looks like I forgot to change some of these over for us. So let me go into this right here. I'll have those edits fixed for the ones you download. But let's just try to do some select clauses here. So a basic one that we can deal with is we could say select star from instructor. Okay. What this will do for us is essentially give us everything back from where we have it, right? We could also say stuff where we say select name from instructor. And then this just gives us the name of each instructor that we're dealing with, right? So again, essentially, you're going to select the table names, the attribute names that you want. That's going to be what you select for in the first, and then whatever's after the from is given it there. Before we get into some more of the complex ideas of it as well, let me try to do select salary. Okay, so we have this salary here. We could also, let's try to do what they said here. So we could select ID, name, and salary as monthly salary. So let's just try to actually, we might be able to copy this code from our PDF into it here. This should be the same. Let's actually try to do this one here. We called it regular ID. Sorry about that. Cool. One more thing here is that we have the as monthly salary. Let's try to actually specify where we're getting this from too. That might be helpful for our code to look at. Cool. So now what we can get here is this type of idea where I'm saying, go ahead and select my ID, name, and salary divided by 12 as monthly salary from instructor. And let's just say we could say, let's say that they get like a 2% bonus in their middle of the year. And let's name this as bonus salary. And now we could say this here. We get this bonus salary down over here too. So one thing I'll show you as well as with these as clauses is that the as is, let's try to type this as first name. The as is kind of similar to that rename relational algebra code that we did earlier. So if I run this one, you could see here that my column names are actually changing. So I could say user ID as first name and so forth. Okay. So one more thing that you might be wondering too is let's try to recreate this. And I just want to show you more about breaking down what's actually going on here. Another way you could type this is instructor.id. Let's just try to remove the rest of this. Let's try to see if I can run this code here. You'll notice here that I keep getting this issue missing from clause entry for table instructor. Select instructor.id. So what we could say here is do the from instructor. Let's try to do this one more time. So now we have this as a bit redundant. Let's try to delete this here. And we're still getting ID as the primary key. One more thing you might notice too that might be a little tricky for us is that this isn't actually the primary key anymore because you're making a new relation, right? So it's not the old one that we're used to, it's the new one that we're looking at. So just be aware of those differences when you're going through this and just be conscious of it, okay? So when we're doing this as, that's a variable name change, that's a rename operation. And please keep this in mind for when we do our join operations later on, because that could get a bit convoluted, especially when you're dealing with multiple tables. But essentially what you're going to do is you're going to rename your tables into a more easier format so that you can type out stuff like instructor ID and then join it on something else. Don't worry about that for now. But again, remember that your select clauses, the form is select from and where for it. Okay. Now we can play around a bit more with this from clause. This is going to list the relations that we can deal with. And again, this is going to be our Cartesian product that we looked at during our relational algebra. So we could say select star from instructor teaches. Let's try to actually do this with our code that we have here. Select all the attributes. I think this will be instructor student. Okay. Cool. So now you'll see here, we get a huge list of data here. And essentially we got our Cartesian product between all of our students and from everyone else that's here too, right? So this will be useful for us to deal with. But again, this is one way. You could see here that we have 4 of the students because each student in our row is matched with all 4 instructors in our instructor table. Okay, so that's going to be your Cartesian product of our from. So that's every possible teacher, and then common attributes are renamed using the relation name. So I think we might actually have one of those in our... We don't unfortunately have one of them, but let's just say... we do with name. Let's see if we can get this one from. So it should be actually showing us the maybe something like student.name or instructor.name. But you could tell here that these names over here are the instructor names that we have, the 4 of them. And then these over here are Jane Smith. So in theory, these should be named with their actual output, but we can just blame the PostgreSQL for that, or pgadmin. So let's go ahead. And one more thing here is that you're never going to actually be doing this like where it's useful. It's going to be useful from this where clause, which I think is what is next here for us. Let me try to do this here. And these are going to be conditions. So the basic ones that we could see here are select name from instructor, where we have a comp sci instructor. Let's try to do a basic, and let me get this as Cartesian product. So now I'm going to say select star from instructor, and let's just go ahead and actually view our instructor table so we can get some good ideas going. So we have CS, math, and biology, and we could say where, so now this is my condition, department name is equal to, and then again, these are all character varying, so they're strings. Let's try to get this one here, okay? So I get all the attributes from there. And now, like, this can be realistic, where it's like, get me the emails of all the people teaching computer science. Now we can get them back there, okay? So this is your usual where clauses, and this is how we can kind of do our conditional flow. One more thing that we see in the where clause conventions is that they are essentially logical operands for it. So the where is going to be the and or not, and it's also going to make usage of those comparison operators that we see quite often too. So we could kind of do something like this here, where we can actually get a more inbuilt operation here. So if we go up to our, let me actually drag this guy back down here so we can just keep running him. So let's try to see where salary is less than, let's try to say 60K, something like this. And we get all the people. If we get something like 50K, I'll actually just kind of copy paste it here. Select all the instructors where their salary is less than 50K. We can see this pulled up. Is that too much? Now let's try to do it one more with the 40. Oh, there's an extra 0. Sorry, I'm blind. Say I planned that. Okay, so now less than the 60K gives us all the instructors. Less than the 50K gives us the tree instructors with the 40K. And now less than the 40K here for us gives us the no one else that's there. And again, you can really play around with this, but just remember that these are your logical operands, right? So we could say this here, execute script. Oops. And let's try to get the less than or equal to running. So this gives us this one. You might notice here that our equals to isn't the equals that we're used to. Apologies for that one too. It's going to be the equals for it, okay? Just bear that in mind. And let's try to do it where we could say something like, and department name is equal to CS. So this should work for us. Okay, but if I change this to math, we don't have that relation inside of our code. So no one's going to pop up, okay? So again, these can get a bit convoluted, or not convoluted, but you can get very powerful conditional flow with this too. And you can really make some operations where it's like, I need every instructor that fits in between these two ranges of salary income, and they belong to these departments because we're going to give everyone in that department a cut or something, or a raise, something like that, okay? So this is what's actually going on with our data place clauses as well. There's also this between comparison operator. And again, 90K and less than 100K. This is going to be a tuple comparison. Let's see it here. And essentially, this between operand is going to be similar to what we saw, what I was just talking about between that range there. So we could actually try to recreate this here. So you could say select from student where I underscore ID. And let me just go ahead and recreate our student table. I'm just going to look at it where the I.ID, and then let's grab up this guy. Oops, sorry. I.ID is between 1 and 2. Let's see what this gives us back here. Cool. So this gives us everything that's between 1 and 2 for our students that have it there within that range. And now, again, this is inclusive. So if I do tree, that will also grab up the tree that I have. So it's not exclusive where it's just less than. It's between these two operands. Cool. So there's a few examples here inside of the slides as well. But again, these can get, easy here. These is where it can get a bit more convoluted, where we can also look at some information here that's in both tables existing at the same time. And if we do this here, we could say select star from student instructor, where we could say something here. So now this is similar to our Cartesian product that we had. So we got all the information that we need. And what I'm going to say is I want where the student.iid. So again, we're dealing with these two different tables that we have here, okay? Is equal to, and let's just do instructor.id. I think that's what we called it up there. So what this will give us is the results from all of the tables of student and instructor, where student.id is equal to instructor ID. So let's actually play a little bit more around with this one, because this is where it can get a little confusing of which table am I actually selecting from. So we notice that both of our tables have the variable or the attribute name, right? So we have name of our student and name of our instructor. What name do we get if we run this one here? We'll get an error. Let's see it here. Error, column reference name is ambiguous. So what this is telling us is that we didn't specify properly which one to select from. So again, from is our kind of predicate clause where it's saying these are the two relations I'm dealing with. And again, remember we relational algebra, we started reading inside of parentheses and then spread out. So we have student and instructor. So our SQL code reads this and it says, okay, I know student and instructors here, but I know name isn't there either. So what I could say here now is I could say, I know that you know student and instructor, so get me the student.name. This will give me the names of all the students there. Alternatively, let me try to copy and paste this. If I do instructor.name, what will this get us here? The instructors for it too. Okay, so we're using pgadmin forward Postgre, and sometimes it's a bit different on how these handle it. But the ambiguous idea is something that you might run into later on when you're dealing with a lot of tables. But let me just type this out for us so we don't forget. So this would be our ambiguous name attribute. This type of code won't run for us because we need to be more specific on what we're trying to do here. Okay. Now, if you wanted to get the student.name, and let's actually just copy it down. So we're trying to get the students that all belong to an instructor. Let's also try to get something a bit more interesting here. We can get the student.name. Oops, I have, sorry about that. Let's get the instructor.email, and then let's get the department name from student instructor, where student ID is equal to instructor ID. So let's run it this way. You'll notice here now that I get my name, email, and department, and you'll also notice that I didn't need to specify instructor for it. Okay, if I delete instructor here, I'm going to get an email is ambiguous, right? Because it's email in both of them. So this is where it can get a little tricky again, as I said, but just be aware of how the structure works for it and how your logic comes true, okay? So if you're dealing with ambiguous names such as this, to specify which one you're going to pick, and then you can go from there. Otherwise, you'll be kind of stuck with this SQL trying to ask you which one to use. So I hope this helps out a bit here for us as well. Again, we're not using primary keys per se and foreign key relations just yet, but we're trying to make a relation occur between these two as well, particularly where we have a student ID is equal to instructor ID. That's our relation there too. There's a bunch of examples you could type up for it too. And in the next video, we're going to be looking at these join operations, which are where we can get very powerful outputs from our code. All right, great work, everyone.